Welcome to Lesson 4 of the course Guidelines for Dashboard Conceptualization. This lesson is about the design of visual components. In the previous lessons, we focused on the various elements, general concepts, ways of visualization, how to visualize quantitative data, and other issues. And now we will delve into certain types of visual components. When we think of visualization, if you remember the previous lesson, we said that the first thing we have to determine is the best way to deliver the story we want to tell. But that is only a part of the battle that we need to fight when building a good dashboard. Also, we have to design in detail each of the visual components that we will use to tell the story as a whole. One of the first things one must not forget is that there is always a relationship between the ink we use and the data that we are representing. And when we speak about good visualizations, we always say that we must use ink to mainly represent the data, and only marginally when it's not exactly for the data. In the graphs now on screen, we see the ink on the left, the ink that we are using to represent the data. Here we see the name of the department, the amount executed, the amount spent, etc. And we can see that all this ink here is exclusively used to represent data. Looking at the graph below, we see that the line bars are drawn in ink. Headings are in ink, the data in the axis are in ink. And when we look at the right side, we can see, for instance, in the example of the table that we had, that there are only two lines used to separate the data from the heading and from their totals. And we say that those two lines are non-data ink. In the case of graphs, if for example we draw two axes, that drawing of the axis is optional, because it is ink that is being used for something other than the data. And so, when we work with the design process, we always have to do some kind of cleaning to ensure that the ink that we are using, in the case of non-data, is minimized to what is actually essential in order to clarify some element in the visualization. But all the rest, all the remaining ink that does not help the explaining of data or to clarify it, must be removed from our design. On the other hand, we must also remove what is not necessary from the ink that we are using to represent the data. For example, if we have a graph, a bar, it is enough to put some color. It is not necessary to add a complicated background or texture, like drawings, etc. Such use of ink does not help us to clarify the message. On the contrary, it can make it more complex. And also, we must use ink when it is necessary to highlight those data that are more important in our visualization. We can also use variations for encoding objects. We should not restrict ourselves to a single type of graphic, like only bars or lines, when there are different options. And, as we will see later on, modern tools allow for visualizations and types of coding that are more and more elaborated and attractive, even visually. And then, as we can see on this screen, there are various ways to encode the objects. Apart from only bars and lines, sometimes it can be as simple as just using dots to identify the location of data in a quadrant, for example. Only the line or a combination of dots and lines when we want to highlight the location of the precise data that is being analyzed. In the case of bars, besides the traditional vertical bars, there may be horizontal bars. There may be dots and bars in a combination, like the one we see on the screen below on the right side. But we must be very careful when we work with bar graphs, because, as we saw during the first lesson, one of the most important things required to build visualizations is to never distort data. Never hide the truth concealed by data. And this is an example taken from the internet, in which we see a graph of various products, and it says that in a survey of consumer loyalty, a specific product exceeded the qualification of its competitors. And when we look at it, there is indeed a strong difference, especially between the one that got the highest score of loyalty and the last one in the graph, that we see down in the bottom. There is 5, 6, or 7 times more loyalty, or at least that is what the visualization in this graph shows. However, This graph makes one of the biggest mistakes that can be made in the representation of data. Instead of starting the axis at 0 when they build the graph, they use 60%. If we rebuild this graph and we represent it this time starting at 0 and not 60% as we see above, we will realize that the difference between the highest and the lowest scores actually is not that big. Such a strong difference is not visualized as seen in this case. Actually, it turns out that the difference is only roughly 20%, while the first graph on top made it seem like almost 80%. And if we look at the difference between the first and the second, it is almost non-existent. While in the original graph, it does seem that the difference is much bigger. This kind of representations hide the truth. Whether sometimes intended or not, it is terrible when they are actually intentional. And we must always be very careful in visualizations not to ever hide the reality of what data are actually showing. We must also be careful with line graphs and not only with bar graphs. In this case, we see a graph that at first sight seems normal. And we immediately say yes. During those 4 years from 1981 to 1985, we see that many cities were visited. And similarly, from 1986 to 1990, and that only a few were visited in the first point. But if we analyze the graph thoroughly, we see that at this level only 2 years are represented, whereas here there are 4 years. So it turns out that in those periods of time where there seem to be more visits, they are talking about much longer periods of time. So we must be careful in that aspect, because once again, the visualization is hiding the truth of what the data represents. And well, I know that many people like to use pies, but we like to say that pies are a dessert. When you look at this pie chart, for example, the one at the top, if I ask you which is the largest area, I'm sure that many would give the wrong answer. It would be very difficult to differentiate, to know that there is a difference between, for instance, A and B. If I ask you which is the largest, probably it would seem that it is B, perhaps C, and actually it turns out to be B. And if we look below, the situation is more complicated because of the perspective. Because many people like to play with the 3D effect, the perspective does not allow to actually visualize the differences between areas. And that is certainly something that we don't want to see in a visualization in which, again, we want the eyes to do the work, to rapidly get to the conclusion and to avoid the brain having to interpret values. Instead of a pie, something as simple as a bar graph allows us to immediately know the answer without any further analysis, that the B area is the largest, even if probably it was not so obvious, and that the second largest, that maybe one would have thought it was A or C, is actually E. Once again, if we want a pie, let's leave that for dessert. And if we want to use a 3D effect, let's leave that for the birthday invitation. But let's not use it in data visualizations, where what we really want is to communicate in a straightforward way. Another very strong tendency in visualizations is to use lines to say, this is where the data is going. And so, in this graph up here, we see that there are several sets of data, but the use of these lines, of this sort of grid that indicates where the data intersect with the months, etc., makes it very difficult to visualize data and the difference amongst them. Moreover, this line almost seems a line from the grid itself when actually it is a data line. This other one is very close and it is hard to visualize it. If we look at the example below, this graph here is much simpler, especially to analyze tendencies. Which ones go upwards? Which ones remain more or less the same? Data does not need to be precise, since we use a historical series to see a tendency over time. We see if it increases, decreases, or remains the same. We are more interested in this than in knowing that this figure is exactly 205,000, for example. If we were interested in the exact piece of data, maybe a table would be more appropriate. And so, in this type of graph, we avoid using lines unless, as we will see ahead, they help to clarify the data. In this distribution graph in quadrants, we have the person's income and his height in inches. And we see the difference between a western region and an eastern region. In this case, a grid is used to assemble as quadrants to know that between 70 and 75 inches, they earn from 50 to 60,000. In this case, the grid is helpful. But if you notice, the line is very discrete, very thin, and does not have the strength as the lines in the axis, for example. So since it is ink that does not go towards the data, we minimize the presence in the visualization. And finally, there is the subject of color. We all love colors. They make us feel happy, in a good mood. Nothing cuter than seeing a rainbow. But maybe we don't need a rainbow in a visualization where we want to see data. When we look at this graph, the number of colors generates in us a feeling of saturation. There are too many colors, there is too much information, and our brain does not know what to do with it. Besides, we have a number of captions on the right side next to it. And it is hard to remember that this purple we see here is the E series, but that this one we see here is the B series. And on top of that, we try to compare the data from a quarter with the other, and another, and another. If, for example, we wanted to know if the D series is increasing or decreasing, this really complicates our reading because we have to go skipping from one data to another, and then we have to check the tendency. Here, we see that it goes upwards, then downwards, and how do we know if the behavior of this series is different from the yellow one, for instance? We have to make a second analysis which makes it more complex, and ultimately, color did not help at all to improve the understanding. On the contrary, it made it more complicated. And so, an important rule should be to only use color when it helps us to convey something else. In line with the example of the rainbow, in this case there are 6 different colors that are talking about the same thing. They are talking, for example, about population per country. Adding a different color does not help to communicate anything extra. In the end, the difference between one column and the other is given by the name of the column that appears down here. It is not the color that makes the difference, it is the name. So it's useless to put different colors. It is easier to look at this graph if we leave in just one color, because if we want to know who this or that one is, we can do so by looking at the names below, and we don't need to try to remember a color code. And when we think of colors, we must be very careful with the color palette that we will use. In another course, Dashboard Visualization, we will see many points related to the use of color and the selection of a good palette. Here, we will only say that it is essential to have a combination of pleasant colors, and not a striking, very aggressive, or highly contrasted combination. The effect of such a color palette is that the user will pay attention to the color and not to the data. And what interests us is that the attention is always focused on the data. Summing up, we must remember, ink is for data, not to decorate. Our representation, our visualization does not need ornaments, figures, or elaborated backgrounds to convey data. Our ultimate goal is to communicate the data. Even if we want to show something aesthetically pleasant, in this case, cute little flowers will not help. We must always preserve data integrity. We must review our visualizations and objects thoroughly to ensure that what we are communicating is correct, and that it conveys the truth in the data, and that it does not seek to deceive, skew, or hide information. We use lines when they help to clarify data. Again, we don't use lines to decorate or because we think that it's interesting. And if we use them, we avoid them to be protagonists. When we have them, they are on the background, and they let the data be what is actually visualized. And finally, let's use color. In this world, black and white definitely are not to be used for data visualization. We use color, but we use it well and only, once again, when they help to clarify data. I leave you with a final thought. A saying from an anonymous author: we don't know where it comes from, but we think it conveys a profound truth, and it says, simplicity is the ultimate sophistication. Sometimes we tend to add a series of ornaments and backgrounds and figures, effects, or objects that distract from visualizing, and we forget that real beauty is found in simplicity.